Hello, this video is all about truncation. So the objective here is to understand what truncation means, how it differs from rounding, and how it affects accuracy. So the key idea, when we round to one decimal place, we look at the digit after the first decimal place and we round. When we truncate to one decimal place, we cut off any digits after the first decimal place. So for example, if we have 6.48 and we round to one decimal place, it's going to round up to 6.5. But if we truncate it, all we do is chop off any digits after the first decimal place. So the first decimal place is 4, so we're going to chop off the 8 because we're truncating, so the answer is 6.4. Here are some examples. So we're truncating 38.789 to one significant figure. So we're going to chop off all of the digits after the first significant figure. So the first significant figure is a 3, so we're going to chop off all of the rest, so it's just going to be 30. The next one is 3 significant figures. So we've got 3 significant figures here, and then we're chopping off all the other digits, so it's just going to be 38.7. So this next one should say 2 significant figures, so I'm just going to change that to a 2. So what we're going to do is look at the first 2 significant figures. So first 2 significant figures are 38, and I'm going to chop off all of the digits after the first 2 significant figures, so it's just going to be 38. This next one is one decimal place, so 38.7 is 1 decimal place, so we chop off all the digits after the 7, so we're chopping off the 8 and the 9, so it's just going to be 38.7. 2 decimal places, we're going to chop off all the digits after the first 2 decimal places, so we're going to chop off the 9, so it's 38.78. Here's another example. So a length is x equals 4.6 centimetres truncated to one decimal place. Find the error interval. So this is a little bit different. So if we draw this out on a number line, we have 4.6. Now the numbers between 4.6 to one decimal place would usually be 4.5 and 4.7. But we don't need to include anything to the left of 4.6 because it's been truncated. We know that the first digit after the decimal place must be a 6. So the lower bound is going to be 4.6 because that's the smallest digit it could be. And then the upper bound is actually going to be 4.7. It can't be 4.7 because 4.7 truncated is just 4.7. But it can be anything up to but not including 4.7. Because even if we had, say, 4.699 truncated, we just chop off the 9s and it's just 4.6. So the bound is going to be 4.6 is less than or equal to x, which is less than 4.7. So the first 3 digits on a calculator display are 74.6. We need to write down the error interval. So we're told that the first 3 digits must be 74.6. So if we write this out on a number line, the first 3 digits are 74.6. 74.6, the next one up would be 74.7. So it can be anything up to but not including 74.7. So the error interval is going to be 74.6 is less than or equal to x, which is less than but not equal to 74.7. So here is a quick-fire practice question on this topic. Pause the video, have a go at this one, and I'll reveal the answer in a moment. Okay, so well done if you managed to have a go at that. So here is the answer, and that's everything for this video. So thank you so much for watching, and I'll see you again in another video. Bye!